Good morning dear students. So today we will be discussing the lab program 2, that is the program to calculate roots of the given quadratic equations. So the input what we will be giving is the value of the coefficient a and a, b, c. This will be the input we will be giving, and the output we will be getting is root 1 and root 2. So we will be getting the output in terms of root 1 and root 2. So as we know that the basic equation of a quadratic is ax square plus bx plus c is equal to 0. So for this particular equation we need to find the roots. So we have formula in order to calculate the roots, that is minus b plus or minus square root of b square minus 4ac divided by 2a, where a, b, c are nothing but the coefficients. Suppose if the user enters a is equal to 0 and b is equal to 0. If the value of a and b is equal to 0, then we are going to get no roots, because if you try to substitute the value of a and b in this particular equation as 0, then the whole term will be 0, that is c. So this if you substitute here 0 and b is also 0 and a is also 0, this whole root will be 0. So we say that if a and b value is 0, then we are not going to get any roots. Okay, so if you so we need to tell the user to give the non-zero values. So the other case will be, so if a, b, c are not 0, means if a, b, c are whole numbers, then the roots depend on this, that is b square minus 4ac. So we have written this, that is b square minus 4ac. Now considering this root is equal to b square minus 4ac, we will be using three cases. We will be analyzing the three cases. So in first case, when d is equal to 0, that is when this b square minus 4ac becomes 0, then we are going to get the root as minus b divided by 2a. So our root will become, that is root 1 and root 2 will be minus b divided by 2a, which means that both the roots are equal. In other case, that is in second case, if this d it becomes greater than 0, then the root 1 we will be getting as minus b plus square root of d divided by 2a. So instead of taking b square minus 4ac, I am just taking square root of d divided by 2a. So the other root will be minus b, so minus b square root of d divided by 2a. So in this case the roots will be distinct or different. Now coming to the case 3, where d is less than 0. So here we will be getting roots as minus b plus or minus square root of d divided by 2a, where root 1 is equal to minus b divided by 2a and root 2 is equal to square root of d divided by 2a. So minus b divided by 2a one term and square root of d divided by 2a is another term. So that is nothing but root 1 and root 2. So we can simply write it as root 1 plus I root 2. So I is nothing but it's a imaginary. So this is of the form x plus iy, that is x plus iy. X is root 1 plus I, y is root 2. Similarly root 1 minus I root 2. So this is nothing but roots are imaginary. So this is the basic concept of the quadratic equation. When coming to the our C program, so this is the program which I have written for the quadratic equation. So I am using the header file, that is the stdio.h and math.h. So since mathematical operations are being carried out, so I am including this hash include math.h. So as I said that the main function, so the execution of a program starts from main. So that's why I have taken main function, that is int main, and I am declaring the variables, that is float a, b, c. These are the coefficients of the roots, and I need to calculate root 1 and root 2 as well as the d value, that is the discriminant value. Now I am asking for the user to enter the three non-zero coefficients. So once the user enters, we need to read it. So I am using the access specifiers, and this is the ampersand of A, B and C. The respective 3 values will be stored in this address. Now as we saw in the condition, when the user enters A is equal to 0 and B is equal to 0, we are not going to get any roots. So when he enters, we need to display a message that is it is an invalid coefficient, and just try again with the valid inputs, because we cannot find roots for the values A is equal to 0 and B is equal to 0. Otherwise if the user enters A is equal to 0, then we are going to get a linear equation where root will be C divided by minus C divided by B. That is the value of root 1. So whatever the root 1 we got, we are going to print, that is root 1 is equal to percentage of f. This is access specifier. So this root will be stored in this variable, that is the root 1. Otherwise we need to take the discriminant value, that is this discriminant is equal to b square minus 4ac. So if this particular discriminant, if it becomes 0, then as we saw in the theory part, that is when d becomes 0, the roots will be equal, and we are just printing the roots, that is root 1 is equal to root 2, that is nothing but minus p divided by 2a will be the value of root 1 and root 2. Otherwise if d is greater than 0, then the roots becomes real and distinct, and respective root value and root 1 root 2 value will be displayed, that is root 1 is equal to minus p plus square root of this discriminant divided by 2a, and root 2 value will be minus p minus square root of this discriminant divided by 2a. So we are going to print the value of root 1 and root 2 in this way. Otherwise when discriminant value becomes less than 0, we saw discriminant is equal to 0, discriminant value is greater than 0. When discriminant value is less than 0, then the roots will be real and imaginary, and the respective root will be, so root 1 will be minus d divided by 2a, and root 2 will be square root of, this is the absolute value of a discriminant divided by 2a. Since we are using this absolute value, we are going to include #include math.h in this particular program. So now we are going to print the value of root 1 and root 2 when roots are real and imaginary. And since we are using int main in our function, we need to return something. So I am just returning 0. 0 is of type int. So that's the reason I am returning 0, and this is the end of the program. So let's try to run this program and see the result. So now it is asking me enter the 3 non-zero coefficients. So I will add 1, 2 and 1. So these are the 3 non-zero coefficients. Now the output what I am getting is roots are equal, and the respective root 1 root 2 value will be shown. Now I need to run one more time to check at the second run, that is when I'll give this time 2, 5 and 2. Now it is saying me that the roots are real and distinct, and respective root 1 and root 2 value will be displayed. Let's try to run one more time, that is for the third run. Now I am going to give my a value as 0, b value as 0 and c value as 4. Now it says that it's an invalid coefficient. Try again with valid input, because I am giving a and b value as 0 where you cannot get the roots. Let's try to run once again. So this time I'll give value of a as 1, b value as 4 and c value as 7. Now I am going to get the roots are real and imaginary, and respective root 1 root 2 value will be calculated. So in this way you can calculate the roots of the quadratic equation with the help of this C program. Thank you.